Hi there, welcome to another burst session on computational fluency for grades 6 to 9 educators. This session is focusing on lesson design to support the development of computational fluency and is co-hosted by Janice Novikowski and Shaheen Musani. When we think about what is computational fluency, and it's a very big idea and big part of our BC mathematics curriculum, it's really looking at the efficient, flexible, and accurate strategies for operating with numbers. So addition, subtraction, multiplication, and division, and a variety of numbers across the grades. At grade 6 to grade 9, we're looking at large numbers. We're looking at small decimal numbers. We're also looking at operating with integers in grade 7 and with fractions and irrational numbers in grade 8. Why do we focus on growing computational fluency? And what do we need to consider as we're doing our instructional planning to, again, support the development of computational fluency? We're looking at developing procedural fluency alongside conceptual understanding and developing students that have mathematical agency and know that they can choose different approaches or different strategies and that there's different ways to approach computation. That students have flexibility in their thinking so that we're providing through our planning choices for them, or that we're asking them to show how they got their solution in 2 or 3 or 4 different ways to promote and nurture that flexibility. And again, we know that computational fluency is grounded in a strong sense of number. So we're weaving that into our instructional planning as well. So before we're operating with fractions or operating with integers, we're making sure students have a strong sense of those numbers and understanding of those numbers before they operate with them. We're weaving in opportunities for students to apply problem-solving skills and competencies in our instructional design, and we're facilitating student confidence in computational fluency through developing mathematical habits of mind and access points so that all students can access the mathematics and that practice of computational fluency so they build confidence over time. Some things that we're going to consider in this session are how do we schedule for mathematics learning? So across the year, across the unit of study, whoops, there we go, we're jumping ahead a little bit, and then across a week, and then within a lesson. And thinking about how we design lessons that provide opportunities for that growth in mathematics, the curricular competencies specifically, and how those develop over the year and over lessons. And then some examples of rich learning opportunities to develop computational fluency skills and apply and transfer them to different contexts. So that's a really important piece in terms of what we know about student learning. If they can't apply and transfer their ability to compute or computation, have they really learned it or understood it? So providing those opportunities for them to apply and transfer. So we have several different schedules that have been posted on the portal that give us sample weeks for planning across kindergarten through grade 7 for those of us that teach in elementary schools. And it's really showing, this is on the grade 6-7 Numeracy Foundation site on the portal, that we're committing at least an hour a day to mathematics instruction. That was really clear in our last curriculum iteration, but those instructional minutes aren't as clear this time around. So again, district expectations or suggestions or recommendations are a full hour a day for mathematics with other opportunities to make connections to mathematics across other areas of learning. So those numeracy experiences in the afternoon or during a soft start in the morning that might connect to ADST or science or social studies, as well as weaving in mathematics and numeracy throughout the day, but a dedicated 1 hour a day lesson to mathematics. This is also parallel in the literacy plans that are shared on the Pillars of Literacy documents on the portal. So you can see here, they've got 3 different types of week plans. The Getting Started week plan, which does include that hour of math a day, the going deeper, the math lessons, and then the integrated lessons, which are more cross-curricular, but are embedding mathematics experiences as well, that hour of lesson, as well as embedding them throughout other areas of learning. So if you haven't seen those, they're on the Pillars of Literacy. And again, if you go to the grade 6 and 7 one, you will see the ones that are specific to grade 6 and 7. So how do we grow concepts over a year in both elementary and secondary? And We do have grades kindergarten through grade 7 year overviews that are posted on the portal. And again, these are just recommendations or suggestions, but they do draw upon what we know about the curriculum, as well as what we know about how students learn. So an example with content, as a grade 6 overview, fractions and decimals are introduced and reviewed in the first term. In order to set students up for success with the new content, which is operations with decimals. And you'll see that that continues in second term and third term. And so that you're not just waiting till third term to operate with decimals, you're introducing that from the very beginning of the year and building on students' understanding over the year. And we know from cognitive science and from psychology that the learning is more likely to stick if it's spaced out over time, as opposed to just doing it all within a 6-week unit of study.
So in high school, particularly in grade 8 and 9, we want to really also continue with that concept and understanding of how to build conceptual understanding of concepts. And to do that, we might think of scheduling some of the content over a semester or over the year, but we can also think about how we can build connections to the various stages of learning and or to the application of the concept in a particular context and to different forms of content. So for example, in grade 8, when we are looking at fractions, we'll be picking up some of the understandings that we've been engaged with in the elementary years, where we've learned how to represent, compare, and order them. But now in grade 8, we're starting to learn various strategies for adding, subtracting, and multiplying and dividing fractions, along with working with order of operations. And so as we're building those concepts, we really need to start to think about how are we going to support students with holding on to that information and making meaning. And so there are other pieces of content in the grade 8 curriculum that this applies to, right? In terms of numerical proportional reasoning, like rates, ratios, proportions, percent, but also when we extend our thinking into probability and then some, right? And so how is it that we're going to explicitly create those connections for students? So before we move forward to start to think about what are options for lesson design, think about what instructional strategies you often use in your practice, why, like what ones are effective, what ones are you're used to doing, what ones do you think students actually apply easily, what routines are, second nature to you. What do you consider when you design your lesson sequences and units? What are you considering in terms of your student needs, in terms of environment? Also, how are you currently addressing the diverse needs of students in your math class in your lesson design? So we'll share a few research-based lesson structures and strategies that you can draw upon to support students in growing their computational fluency skills. It's not an exhaustive list by any means. We're just highlighting a few that we know provide opportunity for students to practice mathematical curricular competencies connected to growing computational fluency, right? So we want to continue to focus on building the curricular competencies that we talked about in our last session, where we're engaging in reasoning, estimating reasonably, working on mental math strategies, looking at how we can visualize and explore math, engaging in communication, whether that be representing our mathematical thinking in different ways, or whether it be sharing ideas using math language and vocabulary. Also focusing on teaching students how to explain and justify their thinking and or the strategies that they're using. But more importantly, how are we supporting students with connecting some math concepts to each other? So one of the structures that may be of focus is to create like a 3-part lesson, right? Where we might be used to doing this in our planning regularly, but when we look at this in terms of through a math lens, in the beginning stage of the lesson, that's when we're starting to activate some prior knowledge, where we're identifying key vocabulary that we want students to use as they're involved in discussion or they're doing a routine. And then during the lesson, we want to dive a little bit deeper and start to either get involved in some sort of an investigation, or we're practicing competencies, or we're introducing materials to explore ideas. We might even engage in like for an entire block, a problem-solving task. And at the end of a lesson, what we want to do is try to consolidate some of that thinking, go back to some of the ideas that surfaced and show how they've grown as a result of our practice during the lesson. We want to reflect on some of that learning and even some of those habits of mind that we've practiced, particularly perseverance, make some connections. For example, if we're working with decimals and we're multiplying and dividing, how do those processes or strategies connect to the ones that we used when we were working with whole numbers? And then we want to offer some practice for kids, right? But anytime that we think about creating a 3-part lesson structure, create opportunities for exploration, create opportunities for investigation, think about what your explicit instruction is going to be and how you're going to structure the learning so that kids know what their responsibility and role is at all points in the learning. So something else to consider when we're wanting to develop computational fluency is the use of instructional routines regularly. So these can be at the beginning of a lesson, it could be during the lesson, right? But these are repeatable strategies, right, that we can use that really think about how it is that we're going to pull from background knowledge, how it is that we're going to build reasoning, what encouraging students to start to communicate their thinking using the language that we are hoping that they build so that they can communicate the processes they're using to find solutions. We want them to also start to practice some of those mental math strategies and connect them to the computational ones that we're developing so that they can begin to realize which strategies are most effective and when they're effective, and they can start to defend their position as to why they're selecting some things over others. Some of the ones that actually are, used often for computational fluency are displayed on your screen. So the number talks are really good for, when we want to create discussion, writing things on the board in terms of what they know, and then building their understanding. Numberless word problems encourages them to really think deeply, make connections to number sense, relationships and things like that while trying to solve. The would you rather, estimation 180, same but different, and which one doesn't belong, all requires students to really think about strategies they're using. They have to be able to explain them in words so that others can understand. They have to use language to have discussions with people in a very respectful way. And then they're defending their decisions. And so this really provides an opportunity for students to practice a lot of those mathematical curricular competencies of focus when growing computational fluency.
So here we have a sample week plan for grades 6 and 7, and this is available on the portal. And the intent is that more of these will be created. So percentages is the focus of this particular week plan, which is a number concept, but there's definitely computation involved in the calculations that students do at grade 6 and 7 around percentages. So calculating percentage discounts and that connection to financial literacy becomes an important part of learning about percentages. But you can see here in this week plan session, the intent is to create a variety of different learning experiences for students with a learning goal in mind. So the learning goal is learning about percentages, and there's different, standards at grade 6 and 7 around that. And then using a problem-solving approach and problem-solving experiences connects those curricular competencies. And again, using concrete, pictorial, and symbolic forms is one of the competencies. Problem solving and applying our understanding is another one of the competencies. But you can see here, on the Tuesday, like Shaheen was talking about those instructional routines, once the students are familiar with them, one of the most important things about instructional routines is that you can get right to the math, because you don't need to talk about the logistics of, oh, how are we going to do this particular task? They know how to do it, so you can get talking to the math right away. And so the students are talking about, how are these two numbers the same and how are they different? And then they move into that math workshop structure, where you may do it as a station approach, where students, rotate through different stations, or you may have materials or tasks out that students can choose from, but they're all focused on developing their understanding of percentages and then developing some of their curricular competencies alongside that. And, ideally, once math workshop is established in your classroom, that is also enabling you as the teacher to work with small groups of 3 or 4 students at a time for just a few minutes at their just right level to support them with a strategy or some understanding or with the material that they need support with. So that's embedded in that structure. And then you can see the closing time, or that after time across the week, there's different ways that students are invited to consolidate their understanding. And this might be a reflection. What did I do? What did I learn? What's next for my learning? They might set a goal for their learning during that time, or they might compare and contrast different strategies that they and their classmates use. And so that can be a sharing time, it can be a reflection time, but it's a really important time for student learning because it allows them to connect their own learning to what they're hearing others are doing.
So something else to consider in your lesson design is to try using vertical non-permanent surfaces. So what that really is they're erasable surfaces. So they could be on whiteboards, blackboards, windows. Some people have the white books, I think they're called, which are sort of like chart paper, but erasable. And displayed around the room. It invites students to work in small groups to tackle some open-ended questions. And so here they're having to work collectively. They're constructing knowledge or learning together, and they're developing their understanding through actually engaging in the activity and through discussion with one another, because as they communicate with one another, they have to synthesize their ideas and agree upon a process for finding or determining a solution. And so on the right-hand side, you'll see that it's also a great opportunity to invite students to reflect on a core competency. And in this case, it was around communication and collaboration. The book that's in the top left-hand corner of the screen that's displayed is Building Thinking Classrooms by Peter Lilledell. And so he offers, one structure around how to use vertical non-permanent surfaces. One thing that we also wanted to consider is how you create your small groups and how you're thinking about your learners. Peter Lilledell often suggests that these groups be mixed and where we're inviting students to work with each other. You can do what is responsive to the needs of your students in the class and dependent on the questions that you want to ask them at their just right level. Another structure that we can try to develop computational fluency is math workshop, which are stations and centers. What's really important to consider in this structure is that students really need to know what their roles and responsibilities are at each of the stations. We generally have 3 stations or 4, depending on the activity that you have. And you can structure the workshop in a couple of different ways. Either they're investigative things that Students will eventually connect ideas to build understanding, but more often you can build math workshop in at regular points to review certain things that you have done. And so the things that are on the tabletops are familiar to students. What you also want to consider with the diverse needs of students is to provide, questions or activities that are going to provide access for all.
So math games are one of the things that you could use as part of math workshops. So once you've taught a game, maybe as a whole class, it becomes then a practice task for students. And by using different cards or different dice or different number ranges or different operations, students can practice at a level, around their math goals. But also math games, there's a lot of research that supports those mixed small groups as well, alongside the Building Thinking Classroom randomized groups, that students are supported in different ways when they're in mixed small groups for math game play. And that it's also important to keep the math really central to the games that you choose. And we have lots of resources available that have information about different math games on the portal. And again, you can see across the bottom, so many math curricular competencies that are developed through the play of math games alongside those core competencies of collaboration and communication as well. So here are some examples of computational fluency math games for grades 6 to 9. Again, there's a math games tile on the 6 and 7 framework and the grade 8 and 9 framework as well. And they're embedded in the week plans, again, under math workshop as a practice task, that sort of intentional, deliberate practice for computational fluency. Again, focusing on all 4 operations: addition, subtraction, multiplication, and division with different types of numbers. So card games like Face Off and Sweet 16, Salute. The students might have been playing Salute since they were in grade 1 or 2 with addition and subtraction. But once you change off to integers and the black cards are, positive and the red cards are negative, then it changes the game in terms of multiplication, division, addition, and subtraction. And then some specific games like Do Your Decimals, Penny, Nickel, Dime, which connects to financial literacy and decimals. Again, lots of resources available for you through the portal on different games.
So we just want to share a few different ways in which we can start to expand a student's understanding of these concepts that we're exploring. So how is it that we can deepen understanding of big ideas that we are working with through the use of math? And that could be through numeracy. For example, right? Numeracy is our ability to be able to solve problems, make decisions, learn more about ourselves and others through using math in various contexts. And while doing so, students draw upon the math concepts that they know, the processes that they've learned, and the skills that they've built. And what makes numeracy come alive is that they start to, also practice their ability to communicate, also some habits of the mind, like perseverance, they are showing and demonstrating, and they're starting to rationalize and reason and analyze the effectiveness of their solutions. So an example like that of a type of strategy that we can use is just to go and find connections to math in our local community. What we see in our screen is during, COVID, where Richmond posted a sign that talked about social distancing. And this is an investigation that students can explore, looking at various math concepts. And this can actually continue to grade 9 when we look at scale, right? Then we can start to provide opportunities for rich problem solving. And so this is where students are engaged in a process for determining a solution to a problem, not just a short problem that has a fixed solution. This is one that could have a range of solutions that are possible, that requires students to work together going through a problem-solving process and ensuring that they are communicating their thinking in various ways while they justify the reasonableness of their answer. Another thing that you can do is start to make some links to bigger forms of instruction like inquiry. So this is something that grade 9 class in our district is exploring. They're looking at the plan and design of a crosswalk in Richmond. This is at Steveston at One Road in Moncton, and read upon why this design was created by the city, but then started to really think about, well, how does that apply to our context? And so they're going to do a little bit of an investigation to collect some data around the traffic use of an assigned region in their school. They're starting to ask some questions around that. And then maybe traffic pattern changes will happen. We'll see. And then this is a project that happened a couple of years ago at an elementary school. Where we're looking at doing some interdisciplinary work. Math can be used to help us deepen our understanding of key ideas that we are exploring in different areas. So this, of course, is related to both science and social studies, and students are investigating the water crisis in First Nations communities. And they're doing some reading in English. They're looking at infographics to get some deeper understanding. And of course, starting to think about the issue, from multiple perspectives. So math is helping them deepen their understanding of that local issue.
And just a little addition to that around focusing back on computational fluency. So these students had learned how to operate with different numbers. This was a grade 5, 6, 7 grouping. And they were applying that in one of the numeracy tasks that we did, trying to calculate how much water would be needed, safe drinking water for a community. And so they had to calculate how many children were in that community based on population data, and then calculate how much water they needed for different things during their day. So there was a lot of computational fluency happening, but an example of an application of that in a meaningful numeracy task.
So if we want to find more information related to computational fluency or ideas for exploration and instruction in your classes, you can look at our Numeracy Foundation framework on the portal. There is a 6 and 7 framework and one for 8 and 9 that gives specific examples to the ideas explored in each of those years. And before we go, just a way to consolidate our thinking is to think about, what do learners need to grow computational fluency? What instructional strategies might support growth in computational fluency? And how might computational fluency be assessed?
Thank you for joining us.